Okay guys, so the next thing that we need to understand are orbital diagrams. And I normally actually teach this at the end. I teach all of the electron configuration and then add orbital diagrams in at the very end. But I'm going to try it this way and teach it before we do a whole lot of electron configuration, because I think it's just going to enhance your understanding of the rest of the unit. Okay, so an orbital diagram is a model of how electrons fill the areas in an atom. And remember, those areas are your principal energy level, your sublevels within that, and the orbitals within that. You have 3 rules that tell us how those electrons behave and how they fill those orbitals. Okay, you have the off-bow rule. We have the Hund's rule, and we have the Pauli exclusion principle. Okay, so the off-bow rule, that is, get some padding under my paper. This is that electrons fill the lowest energy levels first. And that doesn't even just mean in energy level 1, energy level 2. That applies to your sublevels as well. So sublevel S is your lowest energy of all of the sublevels, then P, then D, and then F. Okay, so an example of the the off-bow rule is if you have energy level 1 with an S orbital, an S sublevel, energy level 2 with an S orbital, which we know you've got 1s2 and 2s2, and then on the second energy level comes your p block. So then you had 2p with its 3 orbitals. Your electrons are going to fill energy level 1 first before you bump up to the second energy level. Okay? I'm going to draw these the correct way, but you're not going to know why they're the correct way yet. Okay, so you would fill energy level 2 first. Then, energy level 1 first. Energy level 2 you would move to, and you would fill the entire S sublevel before you move to the P sublevel. Then you would fill in the P. Okay? Hund's rule states that electrons fill orbitals one at a time before pairing up. Okay, so let's talk about this again, this 1s, 2s, and 2p. Okay, these are orbital diagrams that I'm drawing. Okay, so they fill them one at a time before pairing up. Your S's are not a good example of that because they only exist one at a time. Like, you only have one orbital. But your P's, you would fill your orbitals one at a time before you go back in and pair up. Okay? These are like little half arrows, by the way. I just get lazy and draw them like this. Okay, Pauli exclusion principle is going to be the rule that tells you why I've been drawing them up and down. Pauli exclusion states that electrons in the same orbital, so in the same box, have opposite spins. Okay, so Hund's rule is one at a time. Pauli exclusion is opposite spins. Okay, so let's take the same electron configuration, 1s, 2s, and 2p. And they cannot be in the same orbital unless they have opposite spins, right? Because they're both negatively charged. Like, they already don't really want to be next to each other. Okay, so if they have opposite spins, then they can handle it. Okay? So these are the rules for drawing orbital diagrams. And I'm not going to have you doing them along electron configuration just yet because you don't know electron configuration. But I would like to do a few kind of just going from the periodic table and trying some of those together. So let's do the orbital diagram for boron. Okay, so he has, and you have to start at the beginning every single time. You can't, for the full electron configuration. Okay, you can't just say 2p1. Okay, you have to include the entire directions for getting there to boron. So he has energy level 1, which has an S sublevel. Okay, that is a full energy level, because remember, off-bow says you fill your lower energy levels and lower sublevels first. Then he's got energy level 2, he's got an S sublevel, and he has a P. Now P, we're going to draw just a little bit lower, so it's a visual representation of that being, not lower, I guess I should have said higher, a visual representation of that being a higher energy. Okay, so we've got a full 1s2, we've got a full 2s2, right, because boron doesn't even come in until P, so we know those are full. 2p, how many electrons does he have? 1. You don't fill in the other orbitals, you just leave them blank. Okay, so this was for boron. So let's do chlorine. Okay, so start all the way at the beginning, energy level 1. You have your S sublevel. He's full. I'm sorry guys, you couldn't really see. Energy level 2, you have an S, and you have a P. Okay, we're still not there. Energy level 2, chlorine does not come in until energy level 3. So we've got 2S is a full sublevel, and 2P is a full sublevel. I should be filling these one at a time, and then filling them in. Okay, that was like I totally just broke Hund's rule. Okay, then chlorine comes in on energy level 3. Okay, so we've got 3S, 3P, and technically you have 3D. Now chlorine doesn't have any electrons on 3D, right, because 3D doesn't come in on this period. But I just wanted to show you where you would draw that. Okay, so our 3S is full. 1, 2. 3P, he is 1, 2, 3, 4, 5 in. So 1, 2, 3, 4, 5. This guy right here, this single electron is called an unpaired electron. Okay? These, your 3s2 and your 3p5, are called your valence electrons. Don't stress about that yet. You don't need to write these down if you are taking notes. I want to prep you. You will see these terms and things again. Now, we didn't have anything in 3D. However, if you were to be writing something on energy level 4, your S would be here, and notice, well, I probably should have drawn it like up here. This is why 4S comes before 3D. okay, because they're like right here. They're kind of at the same level. So you would have had something in 4s and then 3D, and then you would have come back down to your 4P. Okay? You are not writing these like this for any sort of assignment, assessment, quiz, test. Okay, how you would write that for chlorine is, start at the beginning, 1s2, and I leave myself room for my arrows. 2s2, 2p, and p has 3 orbitals. Okay, so we've gotten through 1s2, 2s2, 2p. We're still not to chlorine. He's down here. Got to start all the way over. 3s2, and then chlorine comes in here at 3p5. You can put your electrons here if you want. You don't have to. And then you start filling in your arrows. You can even split these if you want, so you know to stop with your arrows. Like you want to do 1s2 first before 2s2. That's Aufbau's principle. Go into 2p6, you do one at a time. That's Hund's rule. Before you pair up. When you do pair them up, they're going opposite spins. That's Pauli exclusion. 3p5 is 1, 2, 3, 4, 5. There's your unpaired electron. So why don't you try, I'm going to jot down a few elements, and then you try to do their orbital diagrams, and feel free to come get help from me. Okay? So why don't you try potassium, scandium, and bromine. Okay, you try these, potassium, scandium, and bromine. If you feel lost, confused, behind, come and get help. And then you need to, your assignment is in the packet, page 6. You need to draw 4 orbital diagrams, one for an alkali metal, a transition metal, that's those D block elements, a halogen, and a noble gas. And make sure you read the directions that they all have to be from different periods. Okay, so one from period 1, 2, 3, and 4. Okay?